Hi, once again, welcome back to the 180 math classes. Today we are going to discuss how to find the uh, confidence interval for the difference of two proportions. If you have two binomial experiments with population means P1 and P2, and the alpha is the confidence level, then how to find the error and the confidence interval. You know, the standard deviation of the difference of the populations is given by, proportions is given by sigma is equal to square root of P1 Q1 over N1 plus P2 Q2 over N2, where P1 is the population mean from the first experiment. So P1, and once you got P1, you can find Q1, and Q1 is equal to 1 minus P1, so Q1. And similarly, for the second experiment, you can find Q2 is equal to 1 minus P2, where P1 and P2 are the population means for the respective experiments. Then the difference of the means is given by, denoted by mu, and is given by P1 minus P2. Then their EBP, the error-bound proportion is given by C alpha by 2 into square root of P1 Q1 over N1 plus P2 Q2 over N2. And once you got the EBP, you can find the confidence interval. That is, the general formula is mu plus or minus EBP, and mu is this one, so P1 minus P2 plus or minus EBP. Now, that's the way in which, that's the formula to find out the confidence interval and the error. Okay, now we can do some problems. Now, this is the example. If you have, say, two independent binomial experiments, having first one 60 trials and 41 successes, and in the second one, it is 26 successes out of 54 trials. Then we want to find the margin of error and the confidence interval with a 91% confidence. Okay, so we can find out this one. So first one, the first experiment, the total number is N1, take it as N1. N1 is 60. And so the number of successes is 41. So let us take it as X1, that is equal to 41. And so we can find the probability of the success, that is equal to, let us denote it as P1. P1 is equal to X1 over N1, means number of successes divided by total number of cases, that is the probability. So it is 41 over 60. And that is 41 over 60 equals to 0.6833. So we can round it as 0.68. Now you can find Q1. Q1 is equal to 1 minus P1. That is 1 minus 0.68. And that's equal to 0.32. Okay. That's all about the first one. Okay. So we have P1 here. No. So we have this Q1 here, P1 here, N1 here. P2 here means this one, Q2 here, this one, and N2 here. Okay. Okay, now we are going to find out the sigma, standard deviation of the difference of the means, that is equal to given by P1 Q1 over N1 plus P2 Q2 over N2. Just substitute the values there. P1 is equal to 0.68, Q1 is equal to 0.32 over 60 plus P2 is 0.48 times 0.52 divided by N2 is 54. Okay. Now we can find out the values using the calculator. Okay. Yes, so it is, we can input that values here. So first 0.68 times 0.32 equals divided by 60 equals, I'm going to save it in memory. Then 0.48 times 0.52 equals divided by 54 equals, I add that to the memory again. Now want to take the, so that are adding together, so now we can take the sum of that one, that is this one. So take the square root of that one, so it is 0.09 and the value is 0.0908, so we can round it as 0.091. Okay, so it is 0.091. Yeah, 0.09. Because the third place is 8, that's why I round to the third decimal as this one. Okay, so that is the standard deviation. Now we want to find the z alpha by 2. Okay, so what is the confidence level? The confidence, we want to find a margin of error for the confidence level of 91%. So we can find the alpha value. So alpha is 100 minus 91, that is equal to 9%. So it is 0.09. So alpha by 2 is equal to 0.09 over 2, that is equal to 0.045. Now we can find z alpha by 2 from the Geogebra table. Okay, so for that we can take the Geogebra table here. Here we have to find the probability of that one. It is 0.045. So input that value, then it will be 1.695. So we can take it as 1.695. Okay, 1.695. Okay. Okay. Now we can find the EBP. EBP is equal to C alpha by 2 into, that is sigma, that is square root of this one, P1 Q1 over N1 plus P2 Q2 over N2. That is equal to, we have already know the values of that one, so we just substitute that value. So it is 0.091 times 1.695. We can find out that value from the calculator. Okay, so it is 0.091 times 1.695 equals 0.1542. So we can round it as 0.15. It's 0.15. So that is the error. Okay, so error. Now we can find the confidence interval. So confidence interval is, the formula is mu plus or minus EBP. Okay, so mu is P1 minus P2, that is 0.68 minus 0.48, that's equal to 0.2. 20 actually, so it is 2. Okay, so we can find that value, confidence interval. So it is 0.2 plus or minus 0.15. Okay, so the upper limit is 2.2 plus 0.15, that is equal to 0.35. And the lower limit is 0.2 minus 0.15, and that is equal to 0.05. Okay, so this is the upper limit and this is the lower limit. So what is the meaning of that? So we have the central value, means the point estimate of the difference of the means is mu, and that is 0.2. So we have a point estimate that is equal to 0.2. So the difference of the proportions, the mean difference, the difference of the means of the proportions will be 0.2. That is our estimated value. But we found a confidence, we found an interval with a 91% confidence. We found an interval in which it lies, the lower limit will be 0.05 and the upper limit will be 0.35. So with 91% confidence, we can say that the difference of the means of the two experiments will lie in between 0.5 and 0.35. So this is the point estimation, but in 95% confidence, we can say the value of the mean value, means the difference of the means, this one, difference of the means will always lie between 0.5 and 0.35. That's the meaning. And this difference, that is what is the error, that is 0.35. So we have central value 0.2 and 0.35 is the error. So there is a chance to make that much error, and the lower part and that much error in the upper part. So I mean, it is not the 0.35, it is 0.15, sorry, it is 0.15. So 0.15, that is the error, that is the error. So that much error can be possible, but with 91% confidence, we can say that will lie here. So that's the meaning of that. So the confidence interval is this one, 0.05 to 0.35. So the mean difference, the difference of the means will lie in between these ranges. That is the meaning of that one. Okay, I think you got it. Okay. Now, I'm going to show you how the GeoGebra will give you the answer without this much of calculations. So for that, we have to go to the GeoGebra. Here we have the GeoGebra and take the statistics there. Okay. So we want to input the data here. So first we want to select that one. So it is Z estimate of, no, is the C estimate of difference of proportion. You have to pick that one. Okay. Then find the margin of error. So we have to enter the confidence level there. That is given to be 91%. So we can give it as 0.91 there. Okay. And success. The first one success is 41. So it is, here we have x1 is 41, so we can input that as 41. And n1, that is first n1, that is 60. So we have to input that there. And success of the second one, that is p2, that is x2 is 26. Out of n2 is 54. Okay, that's it. Now we just input that one and say you can see the values there. So this is the interval. Okay, so just watch that one, and the error that is the given there. So you can see the we can verify that with our calculations. Now look at that one. So the interval, it is 0.2019, but we got that as 0.2, right? This is 0.2. And what about the error EBP, that is 0.1538, that we got it as 0.15. Okay. So then what about this one, the sigma value? That sigma value is called the standard error. That is standard error. So that will be 0.09, but we have the 0.091 there. So, okay, so the upper limit, what is the upper limit? 0.35. We can round it as 0.35. This one is that one. Lower limit is 0.048, but it is that can be rounded to 0.05. So when we use the GeoGebra, that will directly give you the values, but we can find the critical value there, that is C alpha by 2. So for that, we need to use the GeoGebra distribution there to find out that one. So that's the different way to find out. The first one is the manual way, and second one is the GeoGebra. Okay, so if you input that values in GeoGebra, it would be very easy to find out. Okay, I think all of you got the idea of that one. And so, yeah, that's it. Have a good day. Okay, so thank you so much. Okay, bye. See you.